So today we'll be dealing with carbon and compounds. Most of the portion in this particular chapter has been eliminated. So we'll start off with carbon and compound. It's a very easy chapter. The portion that you have is very, very, very easy. All right. So, okay, hold on. All right. Okay, so carbon. So if you see carbon, so major things that you have to study is what exactly, why exactly is carbon very important? Okay, and the second thing that you have to study is the way the carbon bonds with others and the speciality of the why carbon is able to form so many compounds, so many compounds. How is it able to form so many compounds? And you have also got to study the speciality of this particular bond. This is a special bond which carbon is not just carbon. Quite a few people actually make this kind of bond. What is the speciality of this particular bond? That also we have got to study. And after that, we have got to study some, regarding saturated compounds, unsaturated compounds. Just a few things that we have to study: unsaturated compounds, and we also have to study some dot structures. We have got to study some dot structures in this. This is very important. We have got to study some isomers in this, and we also have homologous series. This is what we have got to study in this particular chapter, but all of which is pretty easy and simple. All right, now coming again, why is carbon very important? See, carbon is one of the very, very versatile element. Now that is going to create a lot of compounds that we see around. All the papers that you have been using, the cloth that you, natural cloth, if any of the natural cloth, natural material, if you use wool, cotton, anything that you use, jute, all these contains carbon. Any paper you see that contains carbon. Your pencil contains carbon. Living organisms contain carbon. Medicine contains carbon. Everything, any organic substance you take, it contains carbon. So obviously carbon is going to be one of the most important thing, right? So where is carbon present in the nature? Of course it is present in the living organisms. Otherwise you can say that it is present in earth's crust. Crust means the ground level, a few portion beneath the ground level. Earth's crust, in the Earth's crust, carbon is there. About 0.02 percentage of Earth's crust contains carbon in form of carbonate, bicarbonate, and as coal and petroleum. All right, it is contained as coal, petroleum, carbonate, bicarbonate, etc. Now in atmosphere, carbon is present in very less amount. As it is present as carbon dioxide. Carbon dioxide is not an organic compound. Carbonates are also not organic. Bicarbonates are also not organic. Okay, carbon dioxide, carbonates, bicarbonates are not organic. Organic compounds are those which can be easily found in the body. That exactly is not the right definition. But for you guys to understand, organic compounds are generally found inside the living organisms. We can say like that, but it is not the right definition of the organic compound. Okay, now the carbon compounds. See, if you see the carbon compounds, what is meant by a carbon compound? See, carbon does not exist alone in atmosphere. Carbon is going to link with a lot of people, right? So it is going to be found as a family like CH4 or CO2. There are multiple people involved with carbon. So this is not a bachelor. They always exist as family. All right. See, carbon can exist as a bachelor. Then what happens? Allotropes of carbon will come. No, allotropes of carbon will come, and it can turn to a diamond, or it can turn to what? It can be a diamond, or it can be what? Graphite, right? Graphite. These are allotropes of carbon. If you are going for pure carbon, that is only carbon is there in that particular family. All right, these are all bachelors. Now you can either have, so there are many allotropes of carbon. Examples of allotropes of carbon are diamond and graphite. Okay, in diamond, as far as diamond is concerned, diamond does not conduct electricity. Graphite conducts electricity. Graphite conducts. Can you all write lecture notes? At least my kids, can you all write lecture notes, please?
And what about
Diamond
fluorine?
and the
Fluorine.
fluorina. Can you come again? Who was that?
Fluorine.
Fluorine, no. Fluorine, no, fluorine is not.
Not
You were
fluorine.
talking about fluorine, no?
Yeah.
No. Fluorine is not. Fluorine is not at all related to chlorine, carbon for that matter. There are three allotropes of carbon: diamond, graphite, and Buckminster fullerenes. Buckminster fullerenes. Okay, Minster fullerenes. This is not very common fullerenes. This is not a very common allotrope, but these two are very common allotropes. Diamond does not conduct heat and electricity. Graphite conducts heat and electricity. Graphite has a layered structure. Diamond has a three-dimensional structure. All right. Graphite is used as a lubricant. Arvind, are you able to hear, ma? Are you able to hear properly?
Yes, ma'am.
All right.
Ma'am, Savio പറഞ്ഞില്ലേ അത് ഫ്ലൂറിൻ അത് ഞങ്ങളുടെ ക്ലാസ് പഠിപ്പിച്ചത് അതുകൊണ്ട്
Fluorine.
സ്പെല്ലിംഗ് പറയാം FLUORENE.
ഇല്ല, ഫ്ലൂറിൻ എന്ന് പറയുന്ന ക്ലോറിൻ, ഫ്ലൂറിൻ, ബ്രോമിൻ, അയഡിൻ ഇല്ലേ?
അല്ല മാം, അത് സ്പെല്ലിംഗ് വ്യത്യാസമുണ്ട്.
Okay, then I don't know. I am not aware of that. I'll get back to you. I'll write it in the WhatsApp group. Okay, I'll update it in the WhatsApp group. I am not aware of that. നമുക്ക് പഠിക്കാനുള്ളത് ഡയമണ്ട്, ഗ്രാഫൈറ്റ്, ബക്മിൻസ്റ്റർ ഫുള്ളറിൻസ് ആണ് normally, and there are other forms as well. Coal and peat and all those things will have some other compounds mixed with it as well, but those are not considered as allotropes of carbon. All right, so reason I am not aware of that. All right, now coming to next one. So what were we discussing? We discussed about the allotropes of carbon. Now carbon generally exists as in many forms as compounds. Okay, it can join to many different people. Like it can join to hydrogen, oxygen, sulfur, all those things. Now what is the speciality of carbon? What type of bond does carbon form? See, you can form different kind of bonds. See, if you are considering a metal and a non-metal, okay, if you are considering a metal and a non-metal, they generally form ionic bonds. Okay, they have this give and take policy. Okay, the metal is always desperate to give away its electron. I don't want this electron, you are a burden for me. Metal is always going to say that, and the non-metal is like, oh, I want one more kid, I want one more electron, I am desperate for one electron. Now if the metal comes and finds the non-metal, what does it do? Metal gives its electron to the non-metal, and non-metal grabs this electron. Now they can't go away from each other, because they have this particular relationship that one person has given the electron, which makes this one positive. One person has taken the electron, which makes this one negative. Positive and negative are going to stay attracted to each other. Because of electrostatic attraction, they can't move away. Right, so they are going to form this kind of bond is known as ionic bond. Like, please do write lecture notes. Now, is this the kind of bond which is formed by carbon? If you see carbon, it has a twist. What is a twist? See, what is the atomic number of carbon? What is meant by atomic number? Atomic number means the number of protons. Any atom you see, there is a nucleus which is there at the center. All right, so and the electrons are going to revolve around the nucleus. All right, so the number of protons, number of positive charge in the nucleus is denoted as the atomic number. That is kind of the characteristic property of an atom. All right, but generally in a neutral atom, what happens? The number of protons and number of electrons are going to be the same. Neutral atom, for a neutral atom, we are not talking about the ions. All right, for a neutral atom, number of protons and number of electrons are same. So the atomic number of carbon is 6. This indirectly indicates that the number of electrons is 6. So what about the electronic configuration? Electronic configuration is going to be 2,4. Now this is our hero. The outermost electronic configuration, outermost number of electrons in the outermost shell is known as valence electron. Number of electrons in the outermost shell is known as the valence electron. Ladies and gentlemen, every atom has a drive. Every atom has a goal of making itself a noble gas. Well, how do every atom make itself a noble gas? How does every atom attain the property of the noble gas? Every atom tries to make the outermost number of electrons as 8. Every atom wants that the outermost number of electrons should be 8. Okay, that is the janma lakshya of every atom. Okay, now what does it do? So carbon also requires 8 electrons in the outermost shell. So in order to make the number of valence electrons as 8, how much is it required? Either it can lose 4 electrons. See, if it loses 4 electrons, this will be just 2. Okay, electronic configuration is going to be 2. That also is okay because K shell can accommodate only 2 electrons. You guys are clear with that concept, no? So then also it will be a noble gas. That is okay. All right, or it should have, in L shell it should have 8 electrons, or M shell it should have 8 electrons. So the electronic configuration should be either 2, just 2, or it should be 2, 8. This is what carbon is trying to achieve. Okay, so but the issue with carbon is that, see, it has 6 protons in the nucleus. Say 6 protons are there, here 2 electrons are there, and here 4 electrons are there. All right, here 4 electrons are there. I am going to draw this with red color. 1, 2, and 1, 2, 3, 4. Now what can carbon do? Carbon can either receive 4 electrons from outside. See, if it receives 4 electrons, 1, 2, 3, 4, 4 electrons from outside, what is the total number of electrons? Now it is going to be 10. See, the protons which are there are only 6. The 6 protons cannot support the 10 children who are there, 10 electrons who are there. So it will be too weak to support the 10 electrons who are there. What happened, Aravind? Are you not clear with this? Are you feeling sleepy? You are not vibrant as usual. Huh?
This.
Huh? Enna prashna? Okay, the 6 protons will not be able to support the 10 electrons who are going to come. Okay, it will be very difficult. So this is one of the case. Now, what can carbon do otherwise? Say 6 protons are there. All right. 6 protons are there, and K shell is there again 2 electrons, and L shell is there again 4 electrons. All right. So now let us see. I'm going to draw the electrons. 1, 2, and 1, 2, 3, 4 are already there. Now, what can carbon do? It can also lose 4 electrons in order to attain stability. Okay. So in case it achieves 4 electrons, the 8 electrons will be can be fulfilled, but the issue is that the 6 protons will not be able to support the 10 electrons. It can also go ahead and lose the electrons. But will the 6 protons allow the electrons to be lost? No. It is energetically not feasible. It requires tremendous energy to remove 4 electrons from an atom. You can't remove all children from them. No, they will be desperately clinging to their children. If one child is lost, the protons are going to desperately cling to the rest of the children. If another child is lost, extreme desperation will be there. And energetically, it will be not feasible for the carbon to lose 4 electrons. So that option is not also gone. So now nature has come to a conclusion that we need to have some kind of mechanism through which the carbon can attain the 8 shell configuration. 8 outermost electrons should be possible. Now what did they come to a conclusion then? They decided to share the electrons. Carbon decided to share the outermost electron. So the bonds which are formed by sharing the electrons, bonds which are formed by sharing of electrons are known as covalent bonds. The bonds which are formed by sharing of electrons are known as covalent bonds. Now, this covalent bond has many properties. See, if you see, I'll give you one example. Okay, we'll go with oxygen. Anyway, we have to study the oxygen. We have to study hydrogen. We have to study oxygen. I'm going to draw the structure as well. Now, hydrogen, what is the atomic number? Z is 1. That means only one electron is there in the outermost shell. Only one electron is there in the outermost shell. Say another hydrogen has come. Okay, so how many electrons does hydrogen require to attain its Genmalexia? How many electrons does hydrogen require? Huh? One more, right? Because hydrogen only has K shell, and in that K shell, one electron is already there. K shell can attain satisfaction. K shell will be satisfied if it contains 2. All right, so this has a requirement of just 1 electron. Now, when 2 hydrogen meet, they decide that this can neither give nor take. So what do they decide? They decide that we are going to share. We are going to share the electron. So what do they do? Hydrogen and a hydrogen over here. This guy has 1 electron over here, and this particular guy has 1 electron over here. Now, both of them decided to share. Now, what do? This hydrogen slowly extended its boundary to the other one. And this hydrogen, what did it do? This hydrogen slowly extended its own boundary to the other one. All right. Now, they started sharing. When somebody asks this guy, how many electrons do you have? He simply says 2, because this is also part of it. He also says that I have 2. All right. So now 1 pair of electrons is shared. So they are going to share a single bond. If 1 pair is shared, then single bond is created in between them. All right. Now coming to the case of oxygen. All right, now coming to the case of oxygen. Atomic number of oxygen is 8, ladies and gentlemen. So what is the electronic configuration? 2, 6. How many electrons does oxygen require? Oxygen requires 2 more electrons are required. 2 more electrons are required. So when we are drawing the dot structure, we will be drawing only the outermost number of electrons. Outermost electrons will be drawn. All right, so I'm going to draw just 6. All right, 1, 2, 3, 4, 5, and 6. Okay, another oxygen came. Okay, another oxygen came in. This also has 6 electrons. 1, 2, 3, 4, 5, and 6. All right, now what happens? Both of them require 2 electrons each. This also requires 2 electrons, and this also requires 2 electrons. Now what do they do? What do they do? Now they decided to share. Now how do they share? This particular guy, this particular oxygen decided to extend its authority to the other 2 electrons. Now this guy, what did it do? Green one, this also decided to extend its authority to these portion, these 2 electrons. All right, did you understand? Did you understand? Now how many pair of electrons are being shared? How many pairs of electrons are being shared? 2 pairs are being shared. For each pair you draw 2 lines. Now 2 bonds are being formed. Now 2 bonds are being formed. Are you guys clear with this? Are you guys clear with this? Can you try and do nitrogen? Nitrogen, atomic number of nitrogen is 7. So write the electronic configuration, write how many electrons are required, and see what it does when 2 nitrogen meet with each other. Give me a second. So the electronic configuration of nitrogen is going to be 2, 5. Number of electrons required is going to be, it is going to be
3.
Right? So if I put a nitrogen over here, say 1, 2, 3, 4, 5 electrons are there in the outermost shell. I am putting another nitrogen over here. Again, this also will be having 1, 2, 3, 4, and 5. All right. This requires 3 extra. And this also requires 3 extra. So what does this nitrogen do? It extends its attraction to the other 3 electrons of the other nitrogen. This particular nitrogen also is going to extend its attraction to the next 3 electrons of the red nitrogen. Now they are sharing 3 pairs of electrons. So now they are going to form triple bond. All right. So now what happens? They are forming covalent bonds with each other. So what is the speciality of covalent bond? Covalent bond does not have free electrons which are there. As in ionic bond, free electrons will not be there. Only when free electrons are present, only when ions of free electrons are present, can a metal, can a compound conduct electricity, can a substance conduct electricity. Since free electrons are absent as far as covalent bond is concerned, they will not be able to conduct electricity or heat. Guys, do write lecture note, okay? They will not be able to conduct electricity or heat. So covalent bonds are poor conductors of electricity and heat. Now, another point about the covalent bond is that they are, say we have hydrogen, all right, and we have another hydrogen over here. Say in this particular balloon, a lot of hydrogen is there, lot of hydrogen. This is H2, okay, that I am drawing. H2 I am drawing, all right. See the bond between the hydrogen. Bond between the hydrogen is known as intramolecular attraction. Intramolecular attraction, all right. This is very strong. This is very strong. But bond between the molecules, there will be a weak attraction between molecules. All right. This is known as the bond between molecule, or the attraction between molecule is known as intermolecular attraction. This is very less. This is very strong, and this is very weak. Intermolecular attraction is very weak, because of which melting point, even if we slightly heat it, they are going to go apart. When the two people go apart, when hydrogen and hydrogen are closely linked together, two molecules are closely attracted, okay, this is a solid state. When they are slightly apart, now this is the liquid state. When they are far apart, this becomes the gaseous state. This becomes the gaseous state, okay. When you lightly heat it, already the attraction is less. They are desperate to move apart. Slightly, even slightly, I am just telling an example. Hydrogen is already in a gaseous state because it has extremely low melting point and boiling point. So even if you slightly heat it, they are going to move apart, okay. Now this is going to create a liquid, so the melting point is obviously going to be very low. And even if you slightly increase the temperature, they are desperate to go to a gaseous state, so the boiling point also is going to be very less. All right, this is the speciality of the covalent compound. All right, ladies and gentlemen, we will move on to the, can you take 2 minutes and read through this topic, whatever you have written? Definitely dot structure, one or the other dot structure is going to come. So try NH3 and CH4. I'll give you 2 minutes, after which I'll explain. Hydrogen atomic number is 7. Electron configuration is 2, 5. Requires 3. Now, what about hydrogen? Atomic number is 1. Electronic configuration is 1. Requires, don't write requires 7 electrons. It requires only 1 electron. Now it is NH3. So what does it mean? Nitrogen has 1, 2, 3, 4, 5, 6, and 4, 5, just 5. 5 electrons in its outer position. What about hydrogen? Hydrogen has 1 electron in its outer position. So there will be 3 hydrogen coming in. Okay, it can actually satisfy 3. Now this hydrogen is going to extend its attraction to one of the electrons of hydrogen. This hydrogen again, one of the electrons of hydrogen. This hydrogen again extends its attraction to one of the electrons of hydrogen. Now what does nitrogen do? Nitrogen is going to claim the other 3 three electrons which are there in the hydrogen as well. This is how you draw. This is how you draw the structure of NH3. So it will be like NH3. All right, with lone pair of electrons. You don't have to be bothered about this. Just write all these three bonds. All right, this is the dot structure. Are you guys clear with NH3?
Yes, ma'am.
ഉത്തരം പറയട പിള്ളേരെ, എന്റെ പിള്ളേരെങ്കിലും ഒന്ന് മ്യൂട്ട് മാറ്റിട്ട് ഉത്തരം പറഞ്ഞേ.
Yes, ma'am.
Okay, now coming to CH4. എന്താ മോനെ?
N4 എന്ന് പറഞ്ഞ അറ്റോമിക് നമ്പർ ആണ് N-ന്റെ.
N4 ആ? N4 വന്നില്ലല്ലോ മോനെ. N7. This is 7. Ayyo, I was screaming at my child for not writing 7 properly, and now you are asking me if I have written 4. This is 7. അതാണോ ഉദ്ദേശിച്ചത്?
Ma'am, but 5, ma'am, only 5 is there.
And
The
then 2,5. No, when you draw the dot structure, you are supposed to write only the outermost electron. Valence electrons മാത്രമേ വരയ്ക്കുള്ളൂ. You will be drawing only the valence electron. So as far as nitrogen is concerned, I am not bothered about this 2. I will be drawing only 5. So 1, 2, 3, 4, 5.
2, 4, 1 അല്ലേ? 2, 4, 1 അല്ലേ?
Allah, K shell can accommodate 2 electrons. L shell can accommodate 8 electrons. So you will be writing 2,5. Because this can accommodate 8 electrons, no? അത് കാരണം 5 വരെ പോവാം. എന്താ പ്രശ്നം? മനസ്സിലായോ?
Okay, ma'am.
Okay. CH4 പറഞ്ഞു തരട്ടെ. CH4. All right. Try doing it. മനസ്സിലായിട്ട് തന്നെ ചെയ്തോളൂ. Carbon atomic number is 6. So what is the electronic configuration? Electronic configuration എന്താ? ഇപ്പൊ ആരാ എന്നോട് സംസാരിച്ചേ? അയാൾ പറഞ്ഞേ. ആരാ എന്നോട് സംസാരിച്ചേ? I don't know. I am not able to place you. ആരാ സംസാരിച്ചേ? ലിയോ? മനസ്സിലായോ ലിയോ?
Yes, ma'am.
So
2,
there
4.
are 6 electrons coming in. The total number of electrons is 6 because the atomic number of carbon is 6. So what is the electronic configuration? K and L will have 2. K can accommodate a maximum of 2. So two of them are going to go to the K shell, and L can accommodate a maximum of 8. There are 8 beds in L. So, but only 6 people are coming in. 2 have already occupied K shell, and L shell will be occupying 4. So this requires 4 more electrons. All right. Now what about? Now what are we trying to do? We are trying to do CH4. Now hydrogen atomic number is 1. Again, K shell can accommodate 2 electrons. That one is going to go over here, and it requires 1 more electron because K needs only 2 people in total. All right. Now what is going to happen? I am going to draw my carbon over here. I am going to draw only the outermost electrons, which is 1, 2, 3, and 4. Now 4 hydrogen are supposed to come. All right. 4 hydrogen are supposed to come. Now what does it do? 4 hydrogen. We'll draw 4 hydrogen. 1 over here with 1 valence electron. 1 over here with 1 valence electron, 1 over here with 1 valence electron, 1 over here with 1 valence electron. What does this hydrogen do? It extends its attraction to one of the carbon atom. It extends its attraction to one of the carbon atom's electron. Okay, one of the electrons of the carbon atom, one of the electrons of the carbon atom. Now, what does carbon do? Carbon is happy because it is going to claim 4 electrons from all the 4 hydrogen atoms. This is going to be the dot structure. So in this particular case, how do we draw the bond? Hydrogen, 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 and hydrogen. This is methane. Ladies and gentlemen, this is methane. Methane is a very important natural compound which is present in cow dung. Okay, it is part of fuel. A lot of fuels can be made using methane, an important constituent of compressed natural gas. This is very important. Compressed natural gas, CNG, has a lot of methane. CNG has a lot of methane, and it is one of the simplest compounds which are present in nature. All right, ladies and gentlemen. And this is a hydrocarbon. What is meant by hydrocarbon? Hydrocarbon means the compound which contains carbon and hydrogen. The compound which contains carbon and hydrogen. Guys, please draw the dot structure of carbon dioxide as well. That is also important. Try drawing it, carbon dioxide. After which I'll explain. Carbon atomic number is 6. Electronic configuration is 2,4. It requires 4 electrons. And oxygen atomic number is 8. 2,6 is the electronic configuration. It requires 2 electrons, 2 more electrons. So we'll draw carbon over here. It has 4 electrons in the outermost. So while drawing dot structure, we are going to draw only the outermost electrons which are present. So oxygen, let us draw 2 oxygen because CO2, right? Oxygen will have 6 electrons. It requires 2 electrons. 1, 2, 3, 4, 5, and 6. I'm going to draw another oxygen over here. 1, 2. Okay, I'm going to write it with dots. Okay. Dot. 1, 2, 3, 4, 5, and 6. Now, what does this oxygen require? Oxygen requires 2 more electrons. So, what does it do? It attracts 2 electrons from the carbon. What does this oxygen do? It requires 2 more electrons. So, attracts 2 electrons from the carbon. Now, what does this particular carbon do? Carbon attracts 2 electrons each from each of the carbon to itself. So what happened to this? C is here, O is here, and another O is here. All right. So now they form 2 bonds among themselves. They also form between carbon and oxygen. There are double bonds which are present. This is what makes carbon dioxide different. Okay. Double bond is formed between carbon and oxygen. So this dot structure is very important, ladies and gentlemen. You have to study this at home. All right. Are you guys clear with this? Yes?
Yes,
Okay.
Yes,
Okay. Now moving on to the versatile nature of carbon. This again is very, very important. Why can carbon form so many compounds? All right. There are 2 properties which enable the carbon to form so many compounds here. One of them is catenation. Catenation is the capability of the carbon to join with other carbon atoms. Carbon can join with other carbon atom and form long chains of carbon. Long chains of carbon. Okay, carbon can join with other carbon atom and form long chains. It can also form branched chains. It can also form a lot of branched chains. It can also form ring structure. It can also form ring structure. It can also form single bond or double bond or triple bond among itself. So the variety of the compounds which are going to be formed just with carbon linking with each other is extremely huge. Okay. See, other atoms like silicon has the capability of catenation. Catenation means joining with itself. But silicon is comparatively bigger than carbon. It has a huge ego. You know, people with ego can't stay together. No? So the maximum number of silicon which can join among each other is 7 to 8. Okay, carbon 7 to 8, only 7 to 8 can join and stay together. And even if 7 and 8 join together, they have huge ego, huge big people. So even if small thing comes, they are very reactive. They'll break off. But carbon is very small. Very small. It has very less ego, small people. So what happens? Carbon has high attractive force. They can live in heavy joint family. Okay, so they can form long chains, branch chains, ring, double bond, triple bond, and all those things can be formed because the carbon is very small and have high attractive force. So catenation is there in atoms like silicon, but to a very less extent. Even when 7 or 8 silicon atoms join with each other, they're going to be very reactive. So one of the characteristic property of carbon which helps it form a lot of variety of carbon atom is catenation. And the second one being the valency of carbon is 4. See, we have to understand. Now, carbon has 4 valency. Now, it has 4 hands. With these hands, it can join with anyone. See, as I already told you, carbon has very less ego. It can go ahead and join with anybody. It can join with hydrogen. It can join with oxygen. It can join with sulfur. It can join with nitrogen. It can join with chlorine. It can join with fluorine, iodine, anybody. It can join with any people. All right. So now the variety of compounds which are formed as a result of carbon joining with other compounds, other atoms, are very huge. And what is the speciality of this? Say, for example, carbon has, see, we are talking about methane over here. This particular methane has a specific property. Now, what will happen if one of them is replaced by Cl, one of them is replaced by Cl, chlorine? Now, the property, the entire property of this compound is going to be influenced by this particular chlorine. Now, this is a totally new compound. So just imagine another chlorine is over here. So now this is another totally different compound, right? What if an iodine comes over here? Another totally different compound which is going to, whose characteristic is going to be influenced with iodine and chlorine, right? So the number of common, because of this valency, the valency is 4, the multiple bonds can be created with other atoms like oxygen, hydrogen, sulfur, nitrogen, chlorine, etc. And the property of such compounds are going to be dependent on the element which comes other than the hydrogen, which is present other than the hydrogen. So a huge number of compounds can be created. So these are the two properties which enable carbon to form paper, cotton, linen, cotton, wool, etc., etc., etc. Even your whole body is made up of carbon. All right. Now, why is carbon able to form such huge number of long chain or branch chain? It is because the bond formed by the carbon is extremely small. No, extremely strong. Okay. Why is the bond very strong? Because carbon has very less size, very small size. Carbon is extremely small in size. Because of which the nucleus can attract the people who are coming in. Okay, the people who are coming in. So the nucleus attraction is very, very strong because of the small size of the carbon. That is why it is able to form strong bonds, and that is why catenation is very significant in carbon. Okay. So now what happens? Now we are going on to hydrocarbons. The compounds which are formed using carbon and hydrogen are known as hydrocarbons. As far as nature is concerned, the major source of hydrocarbon is petroleum. Hydrocarbons are generally categorized into two types. We already know that: saturated compound and unsaturated compound. When carbon, ladies and gentlemen, when they are linked with each other with just single bond, when carbon single bond is present, when carbon is joined to other carbon using single bond, they are known as saturated compounds. They are known as saturated compounds. So generally, alkanes, we already know this, alkanes are saturated compounds. Okay, how do we name alkanes? How do we name them? Methane. Do you remember all these things? Yes. So if only one carbon is present, the word root is going to be meth, right? So CH4 is methane. How do you draw the structure? Carbon has 4 hands. So H is going to come in all the 4 hands. This is the structure of methane. Now, what about ethane? Ethane means there are 2 carbon which are present. Ane means single bond is present between them. Ane means single bond is present between them. Rest for this particular carbon, 1 hand is already occupied. Rest of the 3 hands, this also has rest of the 3 hands, and hydrogen is going to occupy in other 3 hands. All right. So this is CH3 single bond CH3. This is ethane. If 3 carbon is present, it is prop, bute, pent, hex, heptant, oct. Okay. Are you guys aware of this word root? Otherwise, you will have to by heart this. So for alkanes, as far as alkanes are concerned, the general formula is CnH2n plus 2. So if you see C2H, what is the alkane general formula? Cn, which is C2. 2n plus 2. Instead of n, what should you put? Number of carbon which is there. 2 into 2 plus 2, which is 2 into 2 is 4. 4 plus 2 is 6. C2H6. What about C200? Number of hydrogen is dash. What is it? Number of hydrogen is dash. This is an alkane. So what is it? Cn. So hydrogen is, now here n is 200. So what is 2n plus 2? 2 into 200 plus 2, which is 402. Which is 402. Okay, this is how you should be doing it. Okay, so this is about the alkanes. Now what about the unsaturated compounds? What about unsaturated compounds? Unsaturated compounds are of two types. It can either be alkene, it can either be alkene or alkyne. What is alkene? Alkene means carbon and carbon are joining with each other using a double bond. If carbon joins with another carbon using a triple bond, this is known as alkyne. All right. Now here, this is the simplest alkene which is present. Simplest alkene. The alkene and alkyne are going to start with two carbons. Very important. Very, very important. Please understand this. I will tell you where you are going to go wrong. Third member of the alkene series. They are going to ask you. Third member of the alkene series. What is it going to be? C3. Is it going to be C3H6 or is it going to be C4H8? What is it going to be? It is going to be C4H8 because the alkene series is going to start from C2H4, C3H6 and C4H8, right? So you are going to go wrong here. Same is the case with alkyne. All right. So now we'll see carbon. For alkenes, what is going to happen? Carbon has, I'll just clear this off. I'm going to explain alkene. Okay. Alkene. So what happens? Carbon and carbon is there. Okay. This is the simplest form that we are going to discuss. Since two carbon is there, it starts with H. And since it is a double bond, we call it ene. Ethene. For alkanes, what was it? Alkane. It was methane. Ane comes. Ethane. Propane. When 3 carbon comes, when 2 carbon comes, when 1 carbon comes. But alkene is going to start with the 2 carbon compound and the carbon is going to have a double bond between them. This carbon has already used its 2 hands. Only 2 of the hands are free, which is going to be given to 2 hydrogen. This also gives 2 hydrogen, 2 hands. All right. So this is going to be CH2 double bond CH2. All right. Now what about propene? Carbon, carbon, carbon. Between one of the pairs, we'll have a double bond. Okay. Now what happens? This carbon has given its 2 hands. Now only 2 are free, which will be given to hydrogen. This carbon has used up its 3 hands. Only one hand is free, which is given to the hydrogen. This carbon has used up one of its hands and 3 hands are free for this particular carbon. So that is going to be given to 3 hydrogen. So this is the formula of propene. Propene. All right. So this is the first compound in the series. This is the second compound. So be very, very careful in this. I want you to draw the dot structure of ethene. Ethene. All right. Carbon. This is very important question. All right. Try drawing the dot structure of ethene. Up now, see carbon again. 4 atoms are carbon. The atomic number is 6, 2, 4 and 4 electrons are there in the outermost shell. I'm going to draw it over here. 1, 2, 3 and 3 and 4. Okay. Even at the alkyl, and for this particular guy also there are 4 electrons. 1, 2, 3 and 4. And hydrogen is going to come. Hydrogen has. We'll use pink. Okay. Hydrogen has 1 electron. Oh, what a dirty color. Hydrogen has 1 electron and hydrogen has 1 electron and hydrogen has 1 electron. Now we'll deal with hydrogen first. Hydrogen requires only 1 electron from this guy and it has taken. Hydrogen requires 1 electron from this guy and it has taken. Hydrogen requires 1 electron and it has taken. Hydrogen requires 1 electron and this has taken. Okay. Now what about this carbon atom? This carbon atom is anyway going to claim the electron from the hydrogen. And now what happens? You have to see there are 2 bonds. 2 bonds means 2 electrons are going to be claimed by the carbon. 2 electrons of the other carbon are going to be claimed by the carbon. This particular carbon is going to claim this hydrogen's electron, and since 2 bonds are there, 2 electrons of the other carbon are going to be claimed by this guy. Are you guys clear with this? Are you guys clear with this? So this is the dot structure. This is the dot structure. This is very important. I want you guys to try ethane as well. Okay, let us see alkyne.
Where structure varikalo ma'am? Where structure varikalo? C edit.
C manaslayilla mone endane?
Ma'am, 2 structures varikande.
2 structures are in the 2 structures are.
Ma'am, dot structure, electron dot structure bin.
Okay, alkyne. What happens to the alkyne? Again, it is going to start with triple bond between 2 carbon. So carbon 2 is the first one. Okay, so only 1 hand is free for this particular carbon because 3 hands are being used up. Only 1 hand is free over here. The general formula is going to be CnH2n minus 2, 2n minus 2, and C3. How is it going to happen? C triple bond C and another C. Okay, see here in only 1 hand is free. I'm going to give the other hand to the hydrogen. Here no hands are free for this guy. The poor guy has used up all his 4 hands. Now for this guy, 3 hands are free. So I'm going to give that to 3 hydrogen. Okay, now coming to the dot structure of alkyne. Please try it out. Alkyne. Try that out, and after that I'll explain. The general formula is CnH2n minus 2. Okay, we'll see. Carbon has 4 electrons in the outermost shell. See now, this is going to be 1 electron from this side, 1 electron from this side, and 1 electron from this side. That is why I am drawing 3 electrons over here and 1 electron for the hydrogen. Anyway, carbon is going to have 4 electrons in the outermost shell, and this particular carbon also is going to give 3 electrons to this particular carbon. So I am going to draw 3 electrons on this side and 1 electron on the other side. Okay, now hydrogen comes. So what about hydrogen? Hydrogen is going to come with 1 electron. This particular hydrogen is going to come with 1 electron. So let us have the claim of hydrogen first. Going to take up 1 electron from carbon. Hydrogen is going to claim 1 electron from the carbon. Now what does this carbon do? See, 3 electrons are taken. See, there are 3 bonds, right? So 3 electrons are taken from the other carbon. This carbon is anyway going to take 1 electron from hydrogen, and use up the 3 electrons from the other carbon. This carbon is going to claim these 3 electrons as well. So this carbon is going to claim the other 3 electrons from the carbon and claim the electron from the hydrogen as well. That is how 3 bonds have come. 3 bonds have come in between the carbon. Okay, now this is the alkyne. Now another question which can come is number of covalent bonds. Number of covalent bonds in between propane. Try that out. In between propane. Number of covalent bonds in propane. What is the answer? Try doing that. Number of covalent bonds in propane. What is the answer? So if such a question comes, don't just write 7 or 8 or 5. You have to first draw the structure of propane. What is the structure of propane? Prop means there are 3 carbon. Okay, 3 carbon are there. And ine means triple bond is going to be there in between 2 of the carbon. Now here for this particular guy, only 1 hand is free. The other hand is going to be occupied by the hydrogen. This poor guy does not have any hands free. This guy has 3 hands free, of which 3 are going to be given to the hydrogen. In between, see where you go wrong is in between carbon and hydrogen also, this is a covalent bond which is created. So this is 1. There are 3 bonds over here, 2, 3, 4. This is 5. This is 6, 7, 8. 8 bonds are there. 8 covalent bonds are there in propane. Are you guys clear with that? So you have to draw the structure and then count the number of covalent bonds. Are you guys clear with this? Mother? Yeah?
Yes, ma'am.
Can you all try the number of bonds in butene? We'll do one more, this one. Okay, butene. Try doing it. Number of covalent bonds in butene. Draw the structure first. Butene.
8.
But I don't know. Carbon. So what does it mean? But means there are 4 carbons. 1, 2, 3, 4. Ene means double bond is there between 2 carbon. Now what does this guy have? 2 hands are free. So one hand is given to hydrogen, another hand is given to hydrogen. For this particular guy, only one hand is free. That hand is given to hydrogen. This guy has 2 free, so 2 hydrogen. And this guy has 4 free, so 4 hydrogen. All right. So the number of bond is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Arivinde.
12 ഇല്ലേ?
And the
ആദ്യത്തെ സീയുടെ താഴെ ഒരു ബോണ്ട്.
I did not count this. Even I made a mistake. Up at 12. 12 bonds are there. 12 bonds are there. You have to draw the structure and then only decide. All right. 12 number. So this is how you count the covalent bonds. Okay. So this is regarding the covalent bonds. Now coming to the next topic, which is isomers. All right. Isomers. Isomers are organic compounds with same molecular formula but different structure. Different structure. Okay. So you have to study the most important questions which can come as the isomers of butane, pentane, hexane, and sometimes butene can come. Okay, butene. No, pentene. Sorry, pentene can come. Pentene or pentine. These can come. Okay, but very few. I don't think pentane will come. But you have to be. The most important questions are butane, pentane, hexane. Pentane and hexane. All right. So you have to draw and study all these things. So what are isomers? Say we'll take an example of butane. 1, 2, 3, and 4. The isomers are going to start from butane. Only from butane will carbon show structural isomerism. Only from methane will not show, ethane will not show, propane will not show isomers, structural isomers. Okay. So in this particular case, for butane, this can have another isomer which is like this. They are going to have same formula. Butane formula is going to be C4H10. In this particular case also, if you complete the hydrogen, you are going to see the same formula of C4H10 is going to come. All right. So butane is going to have one isomer. And what about pentane? Pentane is going to have number of isomers which are there is 3. 1. Okay. I'll just show you. We don't have much time. This is going to be the one for pentane. Okay. 3 isomers are going to be there. This is a straight chain. This has 1 branch and this has 3 branches. Okay. And this is the one for hexane. Number of isomers of hexane is going to be 5. Number of isomers for hexane is going to be 5. Okay. Can you all try that out? Hexane. We'll do it very fast. You have to wind up in 10 minutes. Hexane. Try it out and then check. Formula with hydrogen. You have to write it also over here. Okay. This is what just convenience that they have put like this. So this is known as skeletal structure. This is known as skeletal structure. So don't just draw skeletal structure. When this is asked for exams, you have to complete it. Okay. So this is regarding hexane isomers. We have only structural isomers which need to be studied. There are many kind of isomers which are present. Functional isomers are there, chain isomers are there. Many kind of isomers are there. We just have to study structural isomers. Okay. Are you guys clear with this?
Which all should we study for isomers?
Butane, pentane, hexane, and Madhu, there was one question for you, no? Heptina, butina. What was that? Butene, no? Butene and pentene. Okay? These are the commonly asked questions. Butane, pentane, hexane. Heptane is generally not asked. And butene, pentene. This should be fine. This should be fine. Okay? All right. Now coming
Can
to
you show hexanes isomers?
hexane. No, this is this one. It is there in the slide. So try it out once and correct it.
That's heptane, right?
No, down this one. The above one is the heptane and below one is the hexane.
How many structures should we draw? How many structures? If
What
it's heptane,
structures?
hexane.
All structures we should be drawing. Because that is what isomer is about, no? What are the different possible structural combinations which can be taken by the hexane? That is what isomer is. So every structure, we should be drawing all the structures. Okay. Okay. Now coming to a ring structure also you have to study. I think the dot structure is also very important. Ring structure, cyclic structure or ring structure. Okay, say for example, cyclobutane is there. Okay, cyclobutane carbon, 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 carbon. 1, 2, 3, 4. Okay, cyclobutane. This is a saturated compound. Why? Because carbon is joined with each other using single bond. Now, for this particular thing, 2 hands are free. I'm going to give it to hydrogen, give it to hydrogen, give it to hydrogen, give it to hydrogen. What is the general formula for this? C4H8 is similar to butene. Similar to butene. So, as far as isomer of butene is concerned, we can draw this as well. We can draw this as well. You remember, Madhav, we had done this, no? Yeah, I think I had shared it in the group as well. Butene, structural isomer. See, for butene, if you see carbon-carbon double bond, 4 carbon is there. If you write the structure, it is going to be C4H8. So, isomer of butene can also come as ring, cyclobutane. Cyclobutane. Okay, are you guys clear with this? Manslaya? Okay, we have to draw the dot structure as well for this. Dot structure. Can you try and draw one for one of the cyclic compound? For butane, cyclobutane, draw the cyclic structure. Very important question. Cyclobutane, try it out. And write it as a note. Write it as a note. Isomer of butene. Isomer of butene can be cyclobutane. Write it as a note. And draw the dot structure of cyclobutane. So cyclobutane is going to be like this, no? Like this. 4 carbon is going to be there. They are linked cyclically, after which we have to give the other hands to the hydrogen. So I'm going to try an easy way out. So these are linked using single bond. Now what am I going to do is, I am just going to rub this off. Rub this off. These are single bonds which are there in between, right? So I'm simply going to replace it with 2 electrons, because single bond means they are going to share 2 electrons. They're going to share 2 electrons. They're going to share 2 electrons with each other, right? Here also single bond means they are going to share 2 electrons, right? Here 2 electrons each, because everything is a single bond. Everything is a single bond. So 2 electrons. They are going to share 2 electrons each. Okay, they're going to share 2 electrons. Now, first deal with hydrogens. This hydrogen is going to have its claim on carbon. All right. First deal with hydrogen. Then you can take care of carbon. So for this carbon, how was the structure? Hydrogen was here, and it was linked to 2 carbons, right? This is how the structure was. Now, for this bond, the electron should be taken. For this bond, the electron should be taken. For this bond, the electron should be taken, and electron should be taken. So this carbon's ring is going to be like, for this bond, electron should be taken, electron should be taken from hydrogen, and that's the ring. Now, what about this for carbon? How was the ring going to be like? This is how the carbon was linking, right? For this carbon, the electron should be taken for this bond, this hydrogen, and like this. Did you guys understand? This carbon is linked like this. So it should have its claim on the electrons of the other carbon as well, like this. And for this carbon, obviously the link is here, and hydrogen. Okay, this is how it should come. This is how the dot structure is going to be. Okay, draw it beautifully, not like what I have drawn. Okay, all right. So this is regarding the dot structure of cyclo compounds. This is very important, guys. And benzene also you have to study. Carbon. I don't think generally benzene's dot structure is not asked, but it is better if you can learn it and go. There are 6 carbons in benzene. Benzene is an aromatic compound. The formula of benzene is very important. Structure is important. If you are starting off with a single bond, alternate single and double bond. Single bond, double bond, single bond, double bond. Okay, and fill the rest with hydrogen. Hydrogen. This is the structure of benzene. C6H6. If you can draw the dot structure and learn, that also will be good. Generally, that is not us, but it is better to learn and go, because there is not much of things which can be asked from this particular chapter now. So this is an unsaturated cyclic compound. If they ask to write an example of unsaturated cyclic compound, benzene is the example. Now coming to heteroatoms. Just 2 more topics to go, 5 minutes. Okay, that's it. So heteroatom and functional group. Okay, I don't know if it is present, but the topic is present. Anyway, I want you guys to learn this. See, carbon can link with hydrogen as well as other atoms. Say one of the hydrogen is going to be replaced with chlorine. Okay, the atom which replaces hydrogen is known as a heteroatom. Atom which replaces hydrogen in a compound of carbon is known as the heteroatom. Say for example, now this particular heteroatom is going to decide the property of this particular compound. Okay, now instead of chlorine, say instead of hydrogen, another group comes, which is OH. Okay, this is known as the hydroxyl group. OH is going to determine the property of this compound. This is known as the alcohol group. This is the functional group which determines the property of the compound. The group which determines the property of the compound is known as the functional group. Now, what is the heteroatom here? Heteroatom is the oxygen. What exactly replaced hydrogen? Oxygen replaced hydrogen, right? Instead of hydrogen, carbon is giving its hand to oxygen. Okay, so in this case, the heteroatom is oxygen and the functional group is OH. Okay, functional group decides the property of the compound. Now, all right, functional group decides the compound. Now, what about in this particular case, the first scenario that we learned, hydrogen and chlorine. Here, heteroatom is chlorine, functional group is also chlorine. Here, both the heteroatom and the functional group is the same chlorine. Are you guys clear with it? Okay, so this is alcohol, and if you see carboxyl group. Okay, carbon, here hydrogen is there, and for carboxyl group, COOH, the link is going to be to another carbon. Okay, COOH. Okay, so this is the carboxyl group. This is the functional group. Which is there. So here we are considering this carbon. Here we are considering this carbon. So the heteroatom again is going to be oxygen. Heteroatom again is going to be oxygen. So the last carbon which comes in, we will be considering that. All right. So heteroatom again is going to be oxygen, and the functional group is COOH group. Okay. This is carboxyl group. And another keton is there. Keton again, the functional group is going to be oxygen. Functional group is going to be oxygen, and for aldehyde also, the heteroatom is going to be oxygen, and the functional group is CHO. So for aldehyde, it is CHO. For keton, it is CO. For carboxyl group, it is COOH. COOH. For alcohol, it is OH. For all these things, the heteroatom is going to be oxygen. The functional group is given over here. All right, ladies and gentlemen. And the functional group is the one who is going to decide the property of the carbon compound. Now coming to the last topic, which is the homologous series. Homologous series is a series of organic compound. And they are going to have similar structure and chemical property. This is the most important question in organic chemistry. Okay, as far as you are concerned. Now the successive compounds are going to, so we'll write one of the series, which is the alkane series, CH4, C2, H6, C3, H8. Okay, now successive compounds. Here, how many carbon increase? One carbon increase. How many hydrogen has increased? 2 hydrogen has increased. From H4, it became H6. So 2 carbon has increased. Here, from C2, it became C3. So 1 carbon has increased. From H6, it became H8. So 2 hydrogen has increased. So between every pair, there will be an increase of 1 carbon and 2 hydrogen. 1 carbon and 2 hydrogen. If you are considering alkene series, C2, C2H4, C3H6, C4H8. So between two successive members of the series, from C2 it became C3. So 1 carbon has increased. So from 1 H4 it has become H6. So 2 hydrogen has increased. In this case also 1 carbon and 2 hydrogen. So the successive members are going to differ by CH2. Okay, and moreover they are going to show similar property, similar chemical property. As far as physical properties like melting point and boiling point are concerned, they will be showing gradation in property, either slow increase or slow decrease. Why is there a slow increase or slow decrease? Because the physical property generally depends on the mass. Okay, the mass is successively increasing, right? So since the mass is successively increasing, there will be gradual variation in the physical property, but the chemical property are generally going to be same. Okay, and the homologous series is a series of compounds with same elements and functional group, and they can be the series can be represented by same general formula, and the successive members are going to differ by CH2. Most important thing is that they have similar chemical property and there is gradual gradation in the physical property. So we are done with carbon and compounds. Okay. So today evening we will be